What is dependency injection? Dependency injection is a design pattern that allows you to decouple an application from its dependencies. This is achieved by taking an object and explicitly injecting the dependencies it requires rather than having it construct them internally. This helps separate the concerns between object creation and usage, resulting in a program that is more loosely coupled. Loose coupling is beneficial as having components that are weakly linked to each other means that changing one is less likely to have a negative impact on the other. For example, let's represent the object as a car. The car has several dependencies in order to work: an engine object, four-wheel objects, a battery object, and the list keeps going on. For simplicity, let's just focus on the engine object. Without dependency injection, creating a new car object would return the car with a predefined engine installed. For example, for a gas car, it would have a spark-ignited internal combustion engine. Keeping everything in the car constructor may seem beneficial in smaller, specific cases, but what happens if you wanted to change the car model to run off of diesel? As diesel requires a compression-ignited engine, this would require you going into your car class and changing its constructor. Although this is a toy example, you may see that this can quickly lead to dependencies becoming intertwined everywhere throughout the codebase. Instead, what if we perform the creation of the engine outside of the car class entirely? We can define a general engine interface that both the gas and diesel engines can implement. If we decide we want a diesel engine, we can instantiate both the car object and diesel engine object in the main function. We can then assign the car's engine instance variable to be equal to the created diesel object. This is dependency injection. It may seem subtle at first, but as codebases grow larger, you can quickly see its benefits. It makes testing each component of the car much easier as everything is separated with clear boundaries, so the car class only needs to worry about starting the engine irrespective of the engine type, while the specific engine class will take care of everything else. Although this car example is just a demo, you can imagine how dependency injection can be used in real-world projects. For instance, as there are multiple payment processors that have different integrations, you could define a payment interface and have a class that implements it for each processor, such as Stripe or PayPal. That way, if you ever want to add a payment processor such as Square, it simply requires defining a new Square class that implements the payment interface. The rest of the code remains unchanged, as it interacts with the generalized functions that the payment interface exposes, such as subscribe and cancel, not the code specific to the Square implementation. Regardless, I hope these examples provided you with some insight into how dependency injection works. I hope you enjoyed this video, and I'll see you in the next one. Thanks for watching.